Okay, welcome to this weekly for solving absolute value equations and inequalities. We will look at three types of situations right now. The first of the three will begin with an equation, and let's look at this following absolute value equation. And first thing I want to call your attention to is if there is anything that is outside of the absolute value bars, you need to make sure that you take care of that before you do anything, any solving to the absolute value equation. And so in this case, I'm going to need to undo this 5 times the absolute value of c minus 2. How do I undo a multiplication? I'm going to divide. So let's divide both sides by 5, and this will give us c minus 2. Absolute value of that is equal to 6. Okay, now don't forget, in this situation here, we had a 5 outside of the absolute value bars. If there was nothing outside of that absolute value bar, then you could go right ahead to where we are now, and that's set up both your positive and negative case. And so, right here, we will do that. Let's go with the positive case and our negative case. The positive case, we're going to take the c minus 2. That's going to be the positive version of that. Set that equal to 6. The negative case, the c minus 2 will be negative, and that's still equal to 6. Okay, we'll solve for both. Let's add 2 to both sides in the positive case, and we get c equals 8. And let's remember we have a negative 1 that's outside of the absolute, or the parentheses. Sorry. So it's going to be a negative 1c plus 2 equals 6. Let's subtract 2 from both sides. We get negative 1c equals 4, and divide by negative 1, and c is going to be equal to negative 4. Now you want to make sure that you don't forget to check your answer, and so let's double check that. And so if I move all of this over here, give myself some room. So check. Let's see, we go back to our original. 5 times the absolute value of. In this case, we think that our answer, our first one was 8. So 8 minus 2. Is that equal to 30? Well, it would be 5 times the absolute value of 6. And the absolute value of 6 is 6, so it's 5 times 6. Yes. 30 equals 30. So that checks out. Okay, let's try the other case. The other case would be the answer from our negative situation. And so what we would have is check, and we've got the same equation. 5 times, in this case we said it was negative 4, and it'd be minus 2 equals 30. Alright, and so now what we have here is 5 times the absolute value of negative 6 equals 30. Absolute value of negative 6 is 6, and so again we should get 30 equals 30. This does check out. And so make sure that we write our solution set with the fancy brackets, the French brackets. We would have negative 4 and 8. This is not an ordered pair. This is simply listing each single or separate number that is a solution. That is the actual solution set. That is not an ordered pair. Okay, let's go to the second type of review that I want to look at right now, and that is an absolute value inequality. And the example I would like to look at is going to be the absolute value of x plus 2 is greater than 2. Now, because this is a greater than symbol, we are going to have an or type of a situation here when we write out our answer. Okay, there's nothing that's outside of the absolute value bar, so we can set up our two cases. We can set up our positive case, we can set up our negative case. The positive case is simply what is in the absolute value bars. We have x plus 2, and that should be greater than 2. The negative case is the negative version of what is in the absolute value bars. It's still greater than 2. Okay, let's go back and solve. the positive case, let's subtract 2 from both sides. X is greater than 0. And the negative case, just as a reminder, we have a negative 1 outside of the parentheses. We need to distribute that. Let's get a negative 1x minus 2 is greater than 2. Add 2 to both sides. And so what you have is negative 1x is greater than 4. If we divide by negative 1, be very, very careful here. When you multiply or divide by a negative number, you switch the direction of the inequality symbol. Okay. Because we had an OR type of a situation, we have x is greater than 0 or x is less than negative 4. Now if we go to graph this, make sure that we draw our number line, and we definitely need to go just past negative 4. Same thing with 0. Those are the two solutions that we found, and so what we're looking at is negative 4. Anything that is less than negative 4, that would be shaded to the left, and it's an open circle because there's no equal to symbol underneath the less than, and the same goes for the x is greater than 0. Open circle, anything greater than 0 shades to the right. And if we were going to use what is called interval notation, just as a review on interval notation, over in this area here, we're going to make sure that we start out at negative infinity. So we're going to go from negative infinity, moving to the right, up to, but not including 4, because we have the open circle there. So don't include the 4. So use a round bracket. Never include negative infinity, because you cannot include positive or negative infinity. Because this was an OR type of a situation, we're going to use a union symbol. Remember, union, that was OR. Intersection was AND. Alright, now what was the other side of this graph? It started at 0. Does not include 0, so use round bracket or soft bracket, and then this is going to go up to infinity, and just like with the negative infinity, you cannot include positive infinity. And so there is your interval notation. Okay, as was with the first example, I want to look at an example for an inequality where we may have something outside of the absolute value bars. And so let's look at 2x plus 5, absolute value of that, plus 4, and this will be greater than or equal to 1. Now, with number, the first one that we looked at, if there's not anything, if there's something outside of the absolute value bar, we need to move it. It's this plus 4, and so let's subtract that. So once we have isolated the absolute value bars, then we're ready to solve. Okay, so this would give us the absolute value of 2x plus 5 is greater than or equal to 1 minus 4 negative 3. Now, in this case, absolute value, remember everything, anytime you have an absolute value bar, you're going to have a positive result. So this is going to be positive no matter what's in there. Now, we always, or we should know that a positive will always be greater than or equal to, well, greater than negative 3. So no matter what we have here for x, we will have a result that's greater than or equal to negative 3. So in this case, this will always be true because a positive is always bigger than negative 3. So our answer here is going to be infinity, and there's no more solving that we need to do at this point.